Most people assume they understand how aviation works. You book a seat, you show up, the plane takes you somewhere. Simple. But that assumption is the first mistake. Because the aviation system you see, the gates, the departure boards, the neat columns of flight times, is not the system that actually runs the sky. It is a surface, an interface designed to make something extraordinarily complex feel manageable to the people moving through it. Underneath it, the logic is completely different, and once you see it, you cannot unsee it. Start with a question that almost nobody asks. Why do flights from New York to London almost always leave in the evening, not the morning, not midday? Evening, almost without exception, across every airline, every season, every year. The instinct is to say comfort, that airlines schedule overnight flights so passengers can sleep, that it is a service decision, a passenger first choice. It is not. The Atlantic Ocean is one of the most heavily trafficked corridors in the world, and it is also one of the least controlled. Overland, aircraft are tracked by dense networks of ground radar, handed between controllers in real time, monitored with a precision that allows hundreds of planes to share the same sky simultaneously. The moment a flight crosses out over open ocean, that infrastructure disappears, the radar disappears, the real-time oversight disappears. You are flying through a space where traditional control simply does not function. So the system does not try to replicate what it cannot build. Instead, it builds something else entirely, structure in advance. The North Atlantic is divided into a set of predefined routes called organized track systems. These routes are not permanent. They are recalculated every single day, adjusted for wind patterns and traffic volume, then published hours before the first aircraft departs. And here is the detail that changes how you see the whole thing. Those routes run in one direction at a time. Eastbound at night, westbound during the day. The ocean is essentially a one-way highway that reverses itself every 12 hours. This is not about passenger convenience. It is about creating order in a place where order has to be designed in, because it cannot be enforced in real time. But the direction of the routes is only part of the answer. The timing goes deeper than that. At cruising altitude, the atmosphere moves. Jet streams, rivers of fast-moving air flowing west to east, can push an aircraft forward at speeds exceeding 150 miles per hour above what its engines alone can produce. A flight that would take 8 hours against still air can complete in 6.5 with a favorable jet stream underneath it. That is not a minor adjustment. That is the difference between an efficient operation and an expensive one. At night, these winds are more stable. Daytime solar heating disturbs the upper atmosphere, generating turbulence and making precise routing harder. At night, the atmosphere settles. The jet streams become more predictable. The routes can be optimized more reliably. Fuel burn drops, flight times shorten. But even that is not the real reason. The real reason is what happens when the aircraft lands. An aircraft sitting on the ground is not an asset. It is a liability. Every hour a plane is not flying, it is consuming capital. In maintenance costs, in depreciation, in gate fees. Airlines understand this with a clarity that borders on obsession. The aircraft must move. It must always be moving toward the next revenue-generating departure. If a flight leaves New York in the evening, it arrives in London early in the morning. The airport is waking up. The crew is fresh. The aircraft can be turned around and flying again within hours, either continuing within Europe or heading back west across the Atlantic on the daytime return flow. Now reverse the scenario. A daytime departure from New York arrives in London at night, and suddenly everything stalls. Major European airports impose strict noise restrictions on night operations. Arrivals are limited to specific windows. Even if the plane lands, it often cannot depart again until morning. It sits for hours, doing nothing, burning money. Night departures from North America are not a passenger preference. They are the answer to a resource allocation problem that the aviation industry solved decades ago and has never needed to revisit. Now extend that logic beyond passenger aviation entirely. If you open a flight tracker at 3 in the morning, you will see something unexpected. The sky is not empty, it is full of aircraft. Many of them flying routes with no passengers aboard, in aircraft you would never see advertised on a booking site. Wide-body jets running at altitude with nothing inside but boxes. Cargo aviation runs the night shift, and it does so not by accident, but by design, because the night is the only time the system can actually work. Here is the structure. Packages are collected during daylight hours. By evening, they have converged on major distribution hubs. The aircraft arrive. Cargo is offloaded, sorted by destination, reloaded. Within a window of 2 to 3 hours, those same planes are departing again. By the time the passenger terminals are waking up, the packages are already in the air, already hundreds of miles closer to where they need to be. This is not a logistics operation, it is a synchronized machine. Every aircraft, every ground vehicle, every sorting facility running against the same clock. The window is not flexible. If one aircraft is late, downstream connections miss their slots. Packages meant to arrive the next morning do not arrive. The whole chain registers the failure. Night is what makes this possible. Less congestion in the airspace means fewer holding patterns, fewer delays, shorter taxi times. Clearer roads mean trucks move faster between airports and sorting centers. Facilities that would be overwhelmed by daytime volume operate smoothly in the pre-dawn hours. The same physical distance, the same cargo, the same route completes faster at night than during the day. Not because the aircraft is faster, because everything around it is. And then the weather breaks, and you see exactly how fragile this precision actually is. A snowstorm does not just delay packages, it collapses the sequence. Aircraft cannot land, trucks cannot move. Sorting windows close, and the next night's operation begins already behind, already carrying the weight of what yesterday could not complete. The system looks robust from the outside. Inside, it runs on margins that have no tolerance for error. There are people who spend their working lives holding that system together in the moments when it fails, not through algorithms or optimization software, but through presence, through the decision to show up anyway and do what can be done with what is available. That reality is worth remembering when a package arrives a day late and frustration is the easiest response. Now take the same aircraft that flew cargo through the night for 20 years. The one that started its life carrying passengers, business people and families and tourists, before the airline decided it was too old, too inefficient, too much of a liability against the newer models. The one that got retired from passenger service and should, by the conventional understanding of the word retired, have stopped flying. It did not stop flying, it changed what it carried. This is one of the least understood dynamics in commercial aviation. Aircraft do not age the way people assume they age. The calendar year is almost irrelevant. What matters is something more specific, cycles. Every cycle is one pressurization event. One takeoff, one landing, one full expansion and contraction of the fuselage as the cabin inflates to altitude pressure and then releases. The metal breathes, and every breath accumulates fatigue. A passenger aircraft on short-haul routes might complete 10 cycles in a single day. A long-haul freighter flying overnight transatlantic routes might complete one. Both aircraft can be the same age on paper, but their structural condition is not comparable. The freighter has accumulated a fraction of the wear. It may have decades of useful life remaining at the moment the passenger aircraft reaches its limits. Passenger aviation phases aircraft out not purely on structural grounds but on competitive ones. When a newer, quieter, more fuel-efficient model arrives, airlines have to respond. Passengers notice the difference. Regulators pressure airports to reduce noise. Fuel costs cut into margins that newer aircraft protect. The old plane is retired, not because it cannot fly, but because it cannot compete. Cargo does not have that problem. Cargo has no opinion about the age of the aircraft, the noise of its engines, or the presence of entertainment screens. Cargo has one criterion: the cost per ton to move it from one place to another. If an aircraft that has already been fully paid off can meet that criterion, even with higher fuel burn than a newer model, it remains viable. The economics still work, the aircraft keeps flying. This is why the conversion industry exists. Seats come out. Floors are reinforced to handle pallet weight. Large cargo doors are cut into the fuselage. The aircraft that once boarded families heading to summer holidays now loads freight containers in the pre-dawn hours and disappears into the same night sky it always flew. The MD-11 is one example, a 3-engine wide body that once connected continents in passenger service. It burned more fuel than its twin-engine competitors and was gradually withdrawn from airline fleets as economics turned against it. The passenger story ended, the cargo story began. Today, MD-11 freighters still fly regular routes, accumulating cycles slowly, operating profitably, invisible to the people who once flew on them. This is the deeper logic the aviation system never quite announces. The night is not dead time. It is the system's most productive window. The hours when cargo moves. When the Atlantic fills with eastbound traffic. When aircraft that have no reason to sit still keep working. The aircraft that look old to a passenger scanning a departure board are not old in any way the system actually measures. They are measured in cycles, in structural integrity, in the cost of keeping them in the air against the revenue they continue to generate. From the outside, aviation looks like it is organized around people, around comfort and schedules and the desire to arrive somewhere new. From the inside, it is organized around something far more unforgiving. The machine has to keep moving, the night is when it moves best. And the aircraft that seems finished is often only finished with one chapter, still flying, still useful, carrying different cargo through the same dark sky on the same routes by the same logic that built the system in the first place. Efficiency is not a feature of aviation, it is the architecture. Everything else is built around it.